All right, guys, we're going to take a look at another quick lesson. This is actually from the book, section 5.3. We skipped over it earlier in the year because it's a short topic, something that doesn't show up a lot on the AP exam, but it could have one or two questions on it. We're going to take a look at a couple of those questions after this short little lesson, but for now, let's take a look at the expectations for derivatives of inverses. All right, so there's a special relationship between derivatives of inverse relations or functions, and it has to do with those corresponding points. Well, before we get to that, let's talk about what are inverses. Remember, inverse relations or functions have opposite domain and ranges. So the x's become the y's on the inverse, and the y's become the x's. Okay, the domain and ranges flip-flop. So you need to know how to find an inverse relation or function given another function. So here I have a function up here, f of x equals the square root of x. Let's remember how to go ahead and find the inverse of this. Now remember, the first thing you're going to do is switch f of x to y. And then we're going to switch the x and the y. And then we just solve for y. So we got to get rid of the square root, so I'm going to square both sides. And then I'm going to add the 1 over. So this gives us x squared plus 1 equals y. And that's our inverse, and I'm going to replace y with the inverse of f of x symbol, which is f to that negative 1 power of x equals x squared plus 1. So here we have the inverse. So let's go ahead and move that up to here. And now let's take a look at the relationship between their derivatives. All right, well, let's take a look at these. Now remember I said that these have corresponding points where the x's and y's flip. Well, let's see what happens. If I put 5 in here, okay, put 5 in there, square root of 5 minus 1 gives us square root of 4, which is 2. Okay, let's go ahead and put that value in here, the inverse of f of 2. I'm going to put the 2 value in, and 2 squared plus 1 gives us the 5. All right, we see how the x's and the y's flip with these two. These are what I'm going to call corresponding points. Now the derivatives at these x values are going to have a special relationship. Let's see what happens. Let's take the derivative of our square root of x minus 1. Okay, so f prime of x, all right, we bring that 1/2 in front, x minus 1, and that becomes the negative 1/2 power. Chain rule would just be times 1. So this gives us 1 over 2 square root of x minus 1. All right, there's our derivative of this function. Let's go ahead and take the derivative of this one. That's a nice easy one. So the inverse of f of x prime of x. All right, this is just going to be 2x. Nice and easy. Well, let's see what happens if I take the 5 and plug it into here. So if I do f prime of x of 5, we get 1 over 2 square root of 5 minus 1. Well, that gives us 1/4. Okay, if I go ahead and put the 2 into here, into our derivative, gives us 2 times 2, which is 4. What do you notice about those? They're reciprocals. And that's the big relationship between derivatives of inverses. If you take the derivative of 2 inverses at the corresponding points, those x values where if you were to flip these two, at the first x value you'll get a derivative, and at the other x value you're going to get the reciprocal of that previous derivative. Okay, that works every time you're dealing with corresponding points. Let's take a look at another point real quick. Okay, so if we go ahead and let's try 10. we put 10 in here, we know we're going to get 10 minus 1, which is 9. Square root of 9 is 3. So if I put 3 in here, I get 3 squared plus 1, which gives me the 10. So these are going to be our corresponding points. Well, let's look at those derivatives again. We said the derivative of f of x was 1 over 2 square root of x minus 1. If I put 10 into here, I get 1 over 2 square root of 10 minus 1, which is going to give us 1 over 6. All right? Well, here we said the derivative of our inverse was 2x. I put 3 in there. I get 2 times 3, which is 6. Again, reciprocals of each other at those corresponding points. So that's pretty much all there is with derivatives of inverses. This works anytime you take the inverse of a function or you're given information about two inverses. And we're going to take a look at a couple examples on those AP practice problems in a minute. Okay?